Okay, so this is called Draw the Greenhouse Effect. It's in Schoology under today's date, which is the 11th. The greenhouse effect is a natural process that occurs when gases in the Earth's atmosphere trap the sun's heat. So gases in the Earth's atmosphere trap the sun's heat. This process makes Earth much warmer than it would be without an atmosphere. The greenhouse effect is one of the things that makes Earth a comfortable place to live. How does the greenhouse effect work? As you might expect from the name, the greenhouse effect works like a greenhouse. A greenhouse is a building with glass walls and a glass roof. Greenhouses are used to grow plants such as tomatoes and tropical flowers. In the daytime, sunlight shines into the greenhouse and warms the plants and air inside. At nighttime, it's colder outside, but the greenhouse stays pretty warm inside. That's because the glass walls of a greenhouse trap the sun's heat. So I'm going to highlight the fact that in the daytime, the sun shines into the greenhouse and warms the plants and air inside. And that even though it's colder outside, so at night it's colder outside, but the greenhouse stays pretty warm inside. And that's because the glass walls trap the sun's heat. Now, this is talking specifically about a greenhouse, like as if I were going to put my plants in it. But remember, this is called the greenhouse effect. So the Earth has the same exact effect. The greenhouse effect works much the same way on Earth. Gases in the atmosphere, such as carbon dioxide, trap heat like the glass roof of a greenhouse. These heat-trapping gases are called greenhouse gases. Greenhouse gases include water vapor, carbon dioxide, methane, which can be produced by cow farts, nitrous oxide, ozone, and some artificial chemicals known as chlorofluorocarbons. So imagine those gases, carbon dioxide, water vapor, methane, all of those act as that glass. So they trap heat, and then if you guys want, we can highlight some examples of those. So you see how I'm only highlighting that important information. During the day, the sun shines through the atmosphere. Earth's surface warms up in the sunlight. At night, Earth's surface cools, releasing heat back into the air. But some of the heat is trapped by the greenhouse gases in the atmosphere. That's what keeps our Earth at 58 degrees Fahrenheit average temperature. So even though it gets cold, when the Earth releases that heat back, it's like, and if you guys did that drawing, the atmosphere reflects all that heat back in and keeps it inside. How many of you have ever been inside a real greenhouse? They're kind of humid, right? If you've ever, I think some home stores like Home Depot, their outside part, they might treat it like a greenhouse. I know a lot of people here in Florida have them. So we're going to go ahead and let's go ahead and answer the questions, and then we'll draw our picture, okay? Okay. So let's flip to the back. Or actually, let's draw the picture first so that we can reference it for our, and I'm going to separate these just for the purpose. So we're going to draw our picture first. I changed my mind because I feel like it would help us answer our questions better. If you don't have colored pencils, that's okay. It's not going to count against you. So it says draw a sun in the top left corner and color it yellow. So if you don't have colored pencils, it's fine. Just draw a sun. You should know, it shouldn't have to be yellow for you to know what it is. And I'm just going to do this quickly. Okay. Draw an arc around the Earth to represent the atmosphere made up of greenhouse gases. We're going to talk later this week about the layers of the atmosphere. So the atmosphere actually has 5 layers in it. Greenhouse gases are a part of those gases that are in those 5 layers. Have you ever realized, is it warmer when you have more than one blanket or colder? Warmer, because it actually traps heat in between those layers. So think about that too when we talk about the atmosphere later this week. So it doesn't have to be exactly 3 centimeters, but here I've got this represents my atmosphere and the greenhouse gases. Use a ruler to draw 6 orange arrows from the sun to the surface of the Earth. So, and again, it doesn't have to be with a colored pencil, but I'm going to draw 6 orange arrows. 1, 2, 3, 4, 5, 6. So I've got from the sun, and they're moving through those gases initially and hitting Earth's surface. Label them light energy. And I'm going to kind of shade behind it so I know that all of the orange is light energy. So all of these are light energy. Use a ruler to bounce 2 of these orange arrows back out into space and out of the atmosphere to represent the energy that is reflected back to space. So some of these do escape our atmosphere. The greenhouse gases don't trap everything, but they trap most of it. Does that make sense? So I'm going to use these end ones because it's easy. And I'm going to label them. What does it say to label them? Where are you at, guys? What does it say to label them? Number 4. Reflected light energy. Good. These are the ones that are reflected back into space. And if you want, I can label all those, but these are all light energy. And I've got 2 of those that are reflected back into space. Thumbs up when you're ready and you're following me. Okay. So, number 5, use a ruler to draw 2 of these orange arrows bouncing from Earth to the arc that represent the atmosphere, showing how the Earth traps heat in the greenhouse. These arrows can zigzag between the Earth's surface and its atmosphere around the diagram. Okay, so I'm going to take 2 of these, like this one, and they're zigzagging back. Does everybody see? I've got it going this way, and this way. It's trapped. It's trying to get out, but it can't get out. And it said 2 of them. So let's do... So these ones right here are trapped heat. There we go. So I've got 2 that are reflected back into space, 2 that are trapped in the atmosphere, and then it says draw 2 arrows traveling into the earth to represent the sun's energy being absorbed by the land and sea as heat. So we're going to take these 2. And these will be absorbed heat. I think it would have been better if they were all different colors, but whatever works for you. So that absorbed heat is how the ocean water gets heated. It's how the surface of the earth gets heated. We've got gases that are trapped in the atmosphere that make the atmosphere heated, that makes the outside temperature of the air, right? And then we've got some that is reflected back out into space. Does everybody follow me there? Okay. So if I'm going back to my reading, I'm going to go back to my reading. Hey, Emmanuel, make sure that you have what we have, okay? Okay, I don't see that you have what we have. Okay. In your picture though, does the sun touch the earth? Remember, the sun is out here, so it does not touching the earth. So keep that in mind, okay? All right. Just like a glass greenhouse, Earth's greenhouse is also full of plants. Plants can help to balance the greenhouse effect on Earth. All plants, from giant trees to tiny photoplankton in the ocean, take in carbon dioxide and give off oxygen. Actually, we get most of the oxygen that we need from photoplankton in the oceans. Huh? Phytoplankton, thank you. Photo means light. I mean phytoplankton, thank you. In the ocean, which I think is pretty cool. I never would have thought about that. Most people would think we get it from the Amazon rainforest, which is a big portion, but we get most of it from phytoplankton. The ocean also absorbs a lot of excess greenhouse gases. Dioxide in the air is often called a carbon sink because of all the carbon it holds. Color the oceans on Earth blue and the continents green to represent the plant life. So if you don't have colored pencils, again, that's okay. You know what part of the Earth is ocean. You know what part of the Earth is water. There we are. And then I have a video that can also assist with demonstrating this. It's on YouTube, so my suggestion would be if you're watching this video, I can't show that video on my YouTube channel, but I would YouTube videos about the greenhouse effect to get a better visual if you need it. Okay. Draw in factories on the continents, show the carbon being released through burning as gray smoke. Label these CO2 emissions. So on our continents, I'm going to draw, just like it says, little factories. They look like Lego pieces. And they don't have to be perfect, y'all. And it also wants us to draw cars, so because cars give off carbon dioxide. So we'll label them both as CO2 emissions. So CO2, that's carbon dioxide in a abbreviated form. Carbon is C, dioxide, because there's 2 oxygens. So by the end, your paper should look something like this, where we have light energy coming from the sun. Some of that energy is trapped. Some of that energy is released back into space. And some of it is absorbed into oceans and continents. We have things on Earth that are releasing that CO2. We could draw cows on there if we wanted to, because of the cow farts. It's true. And that releases methane. We know water vapor is released in multiple ways, right? So in some of these gases are absolutely natural, but some of them are man-made, which makes the Earth's surface even hotter. So what do you think all of these things right here contribute to? What global problem? I said part of it. What global problem do you think that some of these man-made things contribute to? Caroline. Global warming. Absolutely. Absolutely. And we'll kind of talk more about that. But if you think about the way that we have all of our weather is Earth's way of kind of balancing the carbon cycle in a way, right? So when we notice all of those severe storms, it's trying to balance or to heal itself in a way, if that makes sense. We know that hurricanes are formed by warmer water, right? So if the water is warmer, what do you think we're going to have more of? Hurricanes, right? So think about those kinds of things. Let's go ahead and go back to our questions. If you didn't finish this, you can take this home and finish it. You have the directions on here, right? All right. What is the greenhouse effect? Who can answer this one for me? Carlos. Hey, very good. The warming of the planet due to trapped gases in the atmosphere. Blank is a greenhouse gas. Which one is a greenhouse gas? Brennan? D, yes, all of these. Ding, 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 ding. Without the greenhouse effect, which would be true? Which would be true? Any of my mobile friends have an answer? Which of the following would be true? You guys can respond to me in the chat. I'd love to see what you guys think. Emerson? Absolutely. Just like our bodies need a certain temperature, it's called homeostasis. Or stasis means stable, right? So it's like our stable self. But if we think about the fact that we need a certain temperature to survive, so does the Earth. Remember, the Earth has a bunch of living things on it. They need. How many of you guys have a phone, or you'll notice on the news it tells you if there's going to be a freeze warning, right? I get a notification on my phone that tells me if there's going to be a freeze warning, and I have like 1,000 plants, like, science teacher, lots of plants. So it lets me know that like the living things that I have outside can't survive, right? So I have to move them inside so that they're warmer. So think about that. What do greenhouse gases do? What do greenhouse gases do? I want somebody new. Caroline. A, act as a thermal blanket for the earth, absorbing heat and warming the surface. Perfect. Perfect. All right. Which of the following could happen to light rays from the sun as they hit Earth's surface? Ethan. D as in dog. This makes it hard for me to hear you guys. Yes, so they're absorbed by the land, right? And the ocean. They reflect it back into space, and they're trapped. Trapped. Very good. All right, so this part is all based on the graph. This part is all based on the graph. Observe the amount of carbon dioxide in the atmosphere from 400,000 years ago on the graph. So if we look, let's try to understand what our graph says, right? This is the amount of carbon dioxide, and on this side I have the amount of thousands of years ago before today. So this line right here is current. And then the 1950s is just about right here. So this is 400,000 years ago, 350,000 years ago, 300,000 years ago. Does everybody understand what that graph is showing? Okay. So it says, what can you say has happened to the carbon dioxide levels over that amount of time? What do we think has happened, Mazzy? Very good. Who agrees? Yeah, we see peaks and valleys. You know what was really interesting? What do you think happened when we were all quarantined to the amount of carbon dioxide? What do you think happened to the amount of carbon dioxide? Show me with your hands. Yeah, it went down. It went down. Which made my little science heart happy, my little earth tree hugger heart happy. And I don't know about you guys, but you might have heard on the news that they were noticing significant decreases in the amount of carbon dioxide too. Because why do you think that was? Nobody was outside, but like, what specifically wasn't happening? Yeah, the cars, right? There weren't as many cars on the road. Yes. Yeah, factories had to shut down or limit production, Caroline. And the oceans were colder. I think part of that was because of the time of year, but if you guys went to the beach over the summer, you might have noticed, right? Notice the current level of carbon dioxide. So it's about right here. This is where we're at the current level, because this is 0. How does it compare to the levels of CO2 in the past? How does it compare? There's somebody who hasn't 2 people who haven't participated yet, 3 people. Don't make me call on you. Your names rhyme with Shmendi and Shmayana and Schmishin. Christian? It's about the same as the rest of the graph. What do you guys think? What do you think, Caroline? You thought it was what? B? It's much higher now. I'm going to take a look at something really quick. Only because it might have gotten cut off, and I want to make sure I'm viewing it correctly. What do you think, Emerson? You think it's C? That it's a little higher than in the past? Oh, wait, that's not what I wanted to do. There's a lot of what? Oh, yeah, so the highest point was about 325 years ago. And we're not quite there yet. We're not quite there yet. I would say, let's see. Okay, this is the part that you don't see. So this is the part that you don't see. Because I knew that something was off. So look. Let's take a look at this part of the graph. So I want you guys to fix yours because the copier cut this off. All right, come on. It won't there. All right. It's supposed to be up here. So on yours, do me a favor and fix it. It's supposed to be all the way up here. So make that adjustment on your paper, please. I knew that it cut something off. Oops, wrong. This is the wrong paper. All right, so now what would our answer definitely be? Everybody call it out. B, it is much higher now than ever before. Why do you guys think it's much higher now than ever before? Raise your hand. What do you think, Mazzy? Yeah, so we have more factories and cars. What else? Emerson? Okay, so we have some countries that are just now hitting their industrial revolutions. That means like they're just now starting to build industry. Now in the United States and Europe, this was in the early 1800s that they had the industrial revolution. This is when they had lots of factories. Um, uh, and you'll notice that that's when it kind of started to spike. Look, or you guys can't see now, but it's where it kind of started to spike. Um, we could also think because there's more cattle farming now. Why would there be more cattle farming now? Think about what else might have increased over the past century. The what? What'd you say? Say it. What do you think? Population, right? We have more mouths to feed, right? Um, okay. And then there are the same amount of carbon atoms on Earth now as there ever were in the past, but there are more in the atmosphere um, ever. Blah, blah, blah. But there are more in the atmosphere than ever before. Whoever typed this up made some typos. What explanation you have for this? This is basically what we just said. So why do we think that there's an increase in greenhouse gases? We said because an increase in what population, more, yeah, more, I'm going to say industry and technology. And I'm going to kind of specifically narrow that to an increase in transportation. What do we rely on a lot that produces a lot of carbon emissions? Cars, yeah, but think about what do they thrive on? What is gas considered? It begins with an F. What kind of fuel? Fossil fuels. We burn more fossil fuels. So we could brainstorm different ways to fix this. So what are some solutions do you think that we might have? This isn't on the paper. This is just for us. You guys are literally the future. Like, I mean, this is sad, but so true. This problem, I'm going to be gone before this problem is solved, right? It's up to you guys to create solutions for the future. I can just inspire you to do it. So give me some solutions. What are we thinking? Yeah? Teslas, we've got electric cars to make those more common. You'll notice there are charging stations at the mall. Have you seen the charging stations? My friend's dad, one of my really good friends, her dad is the one that installs those. And he like goes to places to try to encourage them to do that, which I think is a really cool job, right? What else? Yeah, cutting down on oil and gas. So that could be um, by reducing the amount of fossil fuels. It could be by using renewable energy sources, hydroelectric dams, for example. We'll talk about renewable energy, solar energy. How many people have ever seen solar panels on roofs? They're huge in Florida because we are literally the Sunshine State, right? So renewable energy. How many of you have ever heard Leonardo DiCaprio, by the way, is like a climate activist. Not only is he super handsome, but he's also a climate activist. And he is very adamant about reducing the amount of beef that we eat because it reduces the amount of cattle, right? So like we can make changes in small things like our diet. We can make changes, right? So I'm going to say reduce beef consumption. If we reduce beef consumption, that's kind of messy, but if we reduce beef consumption, it can help reduce the amount of farmland that we need, which would make it so that there are more trees to absorb carbon dioxide, right? And it would reduce the amount of methane in the atmosphere. Yeah, 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 yeah. Instead, we could carpool, right? Instead of everybody driving their own cars, we could carpool, use more public transportation. We could bike places. I don't know about you, but I bike to the store sometimes just so that I don't have to get my car out and drive somewhere. A basket, a tisket, a tasket. I bring a little basket. So these are just different ideas. If you guys can think of any, I mean, like I said, I wasn't playing when I said that it's up to you guys to think. People of my generation, we came up with the Tesla. Your turn. It's why it's really, you guys can be mechanical or electrical engineers, right? Chemical engineers. These global scientists or climate scientists. All those jobs are available to you. I'm going to show you guys a little video about the greenhouse effect just to put this in your brain. You will have a quiz this week on heat transfer and then the greenhouse effect, kind of just like a review of this. So please don't throw this away. All right, keep this out because I'm going to check it while you're working on your brochure. Go ahead and get that brochure out while I'm setting this up. From last week. You were here for that. Yes, you were. Remember we folded the paper in 3. We took notes on the different examples of conduction, convection, and radiation. I'm not collecting the brochure until you weren't here so I can give you a rubric. So both of you can come here because it's due on the same day. Yes. Yes. So I'm collecting this at the beginning of class on Wednesday. Sometime this week. All right, here we go. Please pay attention. Good visual, and then you have the rest of the time to work on your things.
It's the living thing. It's just the.
All right, so those of you that are mobile, those of you that are watching or that are watching this YouTube video, you can find this particular YouTube video on YouTube. So I'm going to stop the recording and you can look up what is the greenhouse effect on YouTube and find this specific video.